All right, energy and power in electric circuits. So as we have noted, we have the drift velocity is really small in these wires. And we've said that's because collisions happen so often and so fast that it's really difficult for this charge to flow through the wire as quickly as the electric field wants to be able to allow it to flow. And in fact, this is the really important part and can be a little bit like, wow, how can that be? That over any instant in time, they happen over such a short period of time by comparison to the flow of charge through the wire that we could say that the instantaneous change in kinetic energy is essentially zero. So when we're looking at conservation of energy, as a particle, Q, actually moves from one point to another. What we are going to say is that the work done by the non-conservative forces, and that really comes down to heat, right, will be almost the entire change in the potential energy. So this is why and please get this into your notes, this is why the power equations represent heat generated when we're talking about the electrical power being dissipated. It's always dissipated through resistors. R makes heat. Resistance makes heat. So please make sure you get, again, all of these explosive statements into your notes. And what we get is that when we take our work equation, right, so we have the delta U equals dq times V in terms of the differential, if we're assuming V is constant over a very small differential delta U, we get du dt is power, and you don't need to worry about derivations or justifying the differentials. We will just simply need for our course to memorize power equals IV, since V equals IR, as it shows here, we can use V equals IR, and for the V here to get I squared R, or power equals V squared on R. Power is power, so just like from mechanics, power is watts, which is joules per second. So again, how you memorize things is certainly up to you. I typically memorize power equals IV and then generate I squared R or V squared on R if I need to, if I haven't used them or I'm not using them constantly. Obviously for this unit, if we use them consistently, you shouldn't have to really derive them. You just know IV, I squared R or V squared on R. But in terms of long-term memory, power equals IV is what I remember. So there you have it. Those are our power equations. We'll be using those without the derivations or having to really go into theoretical justifications that are talked about on this page, but we do need them to be able to problem solve numerically, especially for multiple choice questions.